Hello everyone. Today we're going to start explaining what the remainder theorem is. We saw a little bit of this in class, but it was towards the end, so I'm going to explain it again. And the remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is f of c. And I know this is a lot of gibberish and letters and variables and constants and labels, and you might not understand what it's trying to state. So what I'm going to do is I'm going to explain it to you with an example, and hopefully with this example you're able to understand this theorem better. So I'm going to choose an f of x. F of x I'm going to say is equal to 3x cubed plus 8x squared plus 5x minus 7. Okay? And let's say I want to divide this polynomial by a linear term. So I'm going to write, this is the polynomial I'm going to use. I'm going to write 3x cubed plus 8x squared plus 5x minus 7. And I'm going to divide it by x plus 2. Okay? So far, I'm doing what the remainder theorem says. It says take a polynomial and divide it by x minus c, which is a linear term. And remember in class we said x minus c is just a term, a first degree term, or a linear term. X minus c can have many forms. It can look like x minus 1, x minus 3, x minus 10, x plus 5, x plus 3, etc. Whenever you see x minus c, don't think you can only have x minus something, okay? Let me explain this a little bit further. X minus c. This divisor here does not look like x minus a number. It says x plus a number. But one way to see this is x plus 2. I can rewrite this as x minus so that it looks like the x minus c, and I can say x minus negative 2. And now it looks like x minus c, right? I have x minus a constant. And this expression is still equivalent to this one because x minus a negative becomes x plus. So this is an equivalent form of writing x plus 2. And if you rewrite x plus 2 so that it looks like x minus c, then you can easily see what the letter c stands for. I used c as in looking and c as the letter c. Don't be confused. You can easily see what the letter or the variable c, not a variable, the constant c is equal to. So I can say c in this case is equal to negative 2. In class, we had said that to find c, what we do is we solve for x. We take the divisor and we solve for x, and you get that negative 2. So these are two ways, two different ways of finding what that c is, okay? I hope this doesn't confuse you. It's just so that, you know, some people will find it easier to look at it this way. Some people find it easier to just solve for x. Any of the two will work. You get negative 2 for your constant c. So I know what my c is here and what my c is here, okay? Now, it says to take the polynomial and divide it, and that's what we're going to do. And since my divisor is a linear term, I'm going to take advantage of that and use synthetic division, okay? For synthetic division, I'm going to write out my coefficients. I have 3. Make sure that you don't skip any of the powers. If you do, you fill those in with zeros. So here I have power 3, 2, 1, 0. I'm good. That means I don't need to fill in anything. Just write out your coefficients for each of the terms. 3, 8, 5, negative 7. And then here, out here for my divisor, out here I'm going to use what I solved x for, or I can also call this number my c. They're both the same, so negative 2. Remember, we take the first term directly downstairs. Once this is down here, I multiply times negative 2. That gives me negative 6. I write the negative 6 directly underneath the 8, or the next coefficient. I add these two, I get a 2. And then again, 2 times negative 2, negative 4. I add these two, I get 1. 1 times negative 2 is negative 2. And I add these two, and I get a negative 9. Remember, this negative 9 is my remainder. Okay, and in this case, I'm not going to bother with these coefficients because I don't want to know what the quotient is. I just want to know what the remainder is. Now let's go back to our theorem. It says that if I divide a polynomial by a linear term, that's what we just did. Then the remainder, this remainder here, is f of c. What it's saying is that this remainder is also equal to f of c, which is in this case f of negative 2. Let's check that and see if it's true. F of x is equal to 3x cubed plus 8x squared plus 5x minus 7. So I'm going to look for f of c, and c is negative 2. So I'm going to evaluate f of negative 2, which is equal to 3 times negative 2 to the third power. I'm going to evaluate this function for the value of negative 2. That means you write a negative 2 anywhere there is an x in this expression. There it is. And I'm sorry if you hear some background guitar playing and singing. That's my son. Even though I have my door locked, I can still hear him. Okay, so 3 times negative 8 plus 8 times 4 minus 10 minus 7. This is equal to negative 24 plus 32 minus 10 minus 7. And that equals 8 minus 10, negative 2, minus 7, negative 9. It's true what the theorem says. If I take a polynomial and I divide it by any linear term, the remainder I get is also equal to f of c. It's true. So what does this tell me? This tells me that I can evaluate any function by using synthetic division, right? In your book, you're going to have some exercises that are going to ask you, let me erase this. This was from an old recording. I'm sorry about this. Let me get rid of this very quickly. I'm sorry, I forgot to erase this before. Okay. In your book, you're going to have exercises that are going to say, find the remainder when f of x is divided by g of x. For example, I'm going to give you an example like the one you have in your book. Example. It says, find the remainder when f of x is divided by g of x without using division. Okay? So this means whenever we talk about remainder, automatically we think about dividing. So they're going to ask you in your book to find the remainder, but no division allowed. With the theorem you just learned, the remainder theorem, you have just learned a new technique on how to find that remainder. Because you know that the remainder is the same thing as evaluating the function at the value c. So let's say that in this example, f of x is equal to x to the 10th power plus x to the 8th power, and that g of x is equal to x minus 1. Okay? So I'm going to take, it says, take this f of x and divide it by this g of x. So what they're saying is x to the 10th power plus x to the 8th power divided by x minus 1, and they want me to find the remainder without using division. Automatically you think about synthetic division here, especially with this linear term, but we can't do that now because we learned the new technique. The new technique tells me that this is gonna, the remainder I can find by evaluating f of c. Now let's find c. If this is x minus 1, remember we have two ways of finding c. Remember the form is x minus c. So this term already looks like the form x minus c. I don't need to rewrite this. C is equal to 1, right? X minus the c. So the c is 1. Another way you can do this is solving for x equals 1. Okay, so that means that I can evaluate f of 1. And that would be 1 to the 10th power plus 1 to the 8th power. I'm substituting my values here. Okay, anywhere there's an x, I write a 1. And that equals to 1 plus 1, which is 2. This 2 is the remainder that they're looking for, or they're asking me to find. So there you found it without having to do synthetic division, thanks to the remainder theorem. I hope this helps you do your homework and it helps you understand the remainder theorem. I'm sure it will. If you have any questions, you can post any comments on my YouTube channel and I will try to answer them. Have fun with this on the weekend and take care. God bless you.